Hi everyone, let's continue with session 2.6. So we want to talk about the intermediate value theorem. Suppose f is continuous on the interval from a to b, and L is a number between f of a and f of b. Then there is at least one number c in the interval a and b satisfying f of c equals L. So you look at this picture. Okay, so we have A here and B here. Oops. Okay, so and B here. Alright, the function f is continuous from A to B, so you can see it's very continuous. Oh, okay, so let's say L is any number between f of A and f of B. Then when you draw the horizontal line L, there must be a point C such that f of C equals L. So I want to make a story, okay? So you're right here, and your girlfriend is right here across the street. So how do you find your girlfriend? Oh, you must walk through the street to find your girlfriend, right? You cannot jump and over there. So because it's continuous, you must walk across the street to find your girlfriend. You can go here and then come back and go here and there and find your girlfriends. But you must cross the street. Okay, so that's why here we don't know how many times you cross the streets. You cross it at least once. Okay, so here you can cross your street 3 times, right? You can cross your streets infinitely many times. Why? You can go like this, just stay here, and then go there, continue to find your girlfriend, right? So you can cross the streets infinitely many times. You can cross your streets 2 times, right? You can do like this. So you can cross the street 2 times. So, here we don't know where the C is. We just know there is at least a C, one C, okay? There might be more C. Another story is, you have an apple, and then you place your apple on the table, and then you go to the restroom. So after you're back, the apple is gone. Then what happened? You know there must be someone took your apple, but do you know who that is? You don't know. Maybe a student took your apple, maybe a cat took your apple, maybe a dog took your apple, and you don't know how many people or animal took your apple. Maybe 2 students took your apple and then share it. So here we don't know where the number C is, okay? And we don't know the number of the C, okay? Maybe there's 2 value of C words, or maybe there are 3. We don't know the number, and we don't know where the C located. Okay, so that is intermediate value theorem. Okay, so for the theorem, we need to make sure we satisfy the condition, and then after we make sure we satisfy the condition, then we can draw the conclusion. So what are the conditions of this theorem? Well, first, we need it to be continuous. Okay, and second, we need L to be a number between f of A and f of B. Okay, then the conclusion is there is at least C such that f of C equals L. Okay, so this is an intermediate value theorem. When do we use the theorem? Well, we usually use the theorem when we show there is a root for an equation. Well, let's look at this polynomial equation. Do you know how to solve polynomial equation? You know how to solve linear equation, right? You know how to solve quadratic equation, right? Because you have quadratic formula. But how about polynomial equations? In general, it's hard to solve polynomial equations. We have the rational root theorem. If the roots are rational numbers, we can, they're off the list of the rational root theorem. But however, the roots can be irrational. It could be, It could be complex numbers. So in general, any polynomial is hard to find the root. Okay? But however, you can use this intermediate value theorem to approximate to, you can see where the root is locating. Okay? So that's why this is the main use of the intermediate value theorem. Okay? To show there is a root for the equation. So right now, I'm gonna write down the steps of this kind of problem, and then you just follow the steps, and then all of this kind of problems work the same way. Okay, so the first step is define the function. Okay, so define the function. You use the left-hand side minus the right-hand side. Okay, which is, so right now for our example, I'm gonna use the orange color. So, but the black color is fixed. So which means if you see another example, the black color, you just write it down. The logic, the steps are the same, but you just need to replace the sentences for the orange part. Okay, so the left-hand side minus the right-hand side, my left-hand side is 3x to the 7 minus 2x to the 5th plus x minus the right-hand side, which is 1. Okay, so I really hope that when you learn one example, you can summarize the steps. Okay, so then when you see other examples of the same kind, you can find the similarities and differences, and then you can apply those steps. Okay, so this is how you learn one example, and you can generalize of all the examples of the same type. Okay. Next, second step. Oops. Okay, so second step, you want to verify whether f satisfies the condition of intermediate value theorem, which is f continuous? Well, what is f? F is a polynomial. Yeah, it's continuous. And actually, because we're looking at from 0 to 1, we actually only need f is continuous between 0 and 1. But here we have polynomial is continuous everywhere. Okay, so next, you want to show this guy has a root. The equation has a root, so equation has a root that is the same as f has a 0. A 0 is also a root, okay? Let me one more better. Okay, the function has a 0. So, which means you want to find some number that equals 0. F of that number equals 0. So it looks like the L in our theorem is 0. Okay, so we want to show there is at least a number such that f of that number equals 0. So now you want to show 0 is between f of A and f of B. Okay, let's do that. Oops. Okay. What happened? Oops, sorry. Okay. What happened? Alright. Okay. Alright. Okay, so let's see what is, so here is, okay, oops. So we want to find what is f of, so in this case, because we're looking between 0 and 1, so you want to find some number that is positive, and you want to find some number that is negative. So 0 is between them. Okay, so in our example, let's plug in f of 0. So f of 0, we get -1. So f of 0, okay, is gonna be, f of 0 is -1, so it's less than 0, which is which is what we want. Okay, we also need to find a number that is positive. We can try to plug in 1, and you can see f of 1 is 3 minus 2 plus 1 minus 1. 3 minus 2, oh, which is 1. So 1 is positive. See, I have find a number that's f of that number is positive, and I find another number f of that number is negative. So we're ready because now we can use the intermediate value theorem. So we say by intermediate value theorem, there is a C in the interior interval of 0 to 1 such that f of C equals 0, i.e. that is the equation has at least one root in 0, 1. So this is the complete proof. Okay, isn't it very easy? So for a different kind of problem, you just change the orange part. Okay, so keep this in mind. I want you to work on example 8. So pause the video here and work on example 8. And don't be lazy, copy everything. Don't just write down the orange parts. Are you ready to check the answer? Yes, let's do it. First, we define f of x. What is f of x? Well, your left-hand side minus the right-hand side. What is your left-hand side? X sine x minus 1. Minus the right-hand side, which is 0. So this is our function, right? And then second step, you want to verify the conditions of the intermediate value theorem. So i.e. f is continuous. Is it continuous? Yeah, linear function is continuous. Sine x is continuous everywhere. So f is continuous. 3, we want to find a number. F of that number is positive. And we want to find another number. F of that number is negative. So f of 0. Let's see when we plug in 0. Oops, sorry. I should use orange color because this is only for this problem. So for other problem, you want to plug in different points, of course. So f of 0, 0 times 0, 0 minus 1. Oh, you see, this is negative. And f of we can plug in 2. So sometimes the problem might not giving you those values. Well, then you want to find some point to plug in, such as f of one point is positive, f of another point is negative. Well, you usually try 0, see whether it works, okay? And then to find the other points, you want to try 1. So if this guy and this guy, they're of the same sign, then you try minus 1 to see whether this guy and this guy are of the different sign. Okay? You can try more number, maybe try 10 or minus 10. Anyway, but you want to find a number that is f of that number is of different sign of f of 0. Okay, everybody? Let's continue. So f of 2, we have 2 sine 2 minus 1. Here, be careful. So in our course, when you want to calculate the trig functions, always use radian. Don't use degree. Okay? So sine 2, make sure your calculator is in the radian mode. Okay? So when you plug in it, yeah, let me plug it in my calculator. So 2 times sine 2 minus 1 is approximately equals 0.81859. And you can see this guy is positive. See, I have found a number, f of that number is positive. Then I can say by intermediate value theorem, there is a C and 0, 2 such that f of C equals 0, i.e. equation has at least one root in 0, 2. Okay, so here we have a remark. Intermediate value theorem only tells us the existence of a root, but it does not tell us how many roots are there. To find the exact number of roots, we will need to look at the graph or use mean value theorem in the later session. So the mean value theorem in the later session, this is session 4.6. Okay, yeah, a long time. Right now we're at 2.6, and then this is in session 4.6. Okay, so after we learned the mean value theorem and coupled with the intermediate value theorem, we can show that the equation has exactly one root, or we can know how many roots that the equation has. Okay, everybody? So that is chapter 2. So please review, and then when you have any questions, feel free to email me. Have a nice day. Bye.